All right, this is Mr. Barre, and we're talking about the transitive property. So right here, I've got 4 quarters, and 4 quarters equals $1. And I have 10 dimes, and that equals $1. And since this equals $1 and this equals $1, we know that these two things actually equal each other, that 4 quarters equals 10 dimes. That's the transitive property. Now, it doesn't have to do with money. I can do it with other things also. It's going to seem weird, but I can do it with fruit. If this orange costs the same as the banana, and this orange costs the same as an apple, if the orange equals a banana and the orange equals an apple, then we know that the apple equals the banana. They're the same. If these guys cost, let's put some prices on this. If a banana, an orange costs $1, and an orange costs $1, and a banana costs the same as an orange, so it costs $1, and an apple costs the same as an orange, it costs $1, that means these two guys are equal. They cost the same amount of money. Let's do this with slope-intercept equation. If y equals 4x minus 3 and y equals 2x minus 9, ready? Actually, I'm going to do it like this. That means that these two guys are equal to each other. Y is like that dollar, it's that joining thing, it's like the orange. If y equals this and y equals this, then 2x plus 9 equals 4x minus 3. The y is like the dollars. It's just the exact same thing except with the dollars. Here it is with dollars, right? Is that 10? 1, 2, 3, yep, they're okay. Right? It's the exact same thing. This is the 4 quarters, these are the dimes, these are the dollars. That's the transitive property. It's going to let us take 2 slope-intercept equations and join them together. All right, that's it. Thanks for watching.
Hey, this is Mr. Barre, and it's time to take some notes. So this is the 3rd day that we spent getting ready to solve systems using substitution. And we're actually going to use it today. We're going to take the last 2 lessons and put them together and start solving systems using a substitution method. So we are trying to solve real-life linear problems or linear systems problems. Line equations will help me understand the world around me and make predictions. Yes, you can solve a system by graphing, but can we solve a system another way? Today, we're going to put together the last 2 lessons and solve systems without graphing it. We're going to skip over this. Actually, so this is where we started. We started with the idea of, hey, if x equals 3, we can plug it in and get the y. So let's do this one in our notes. So in our notes, we're going to do name, the title, which is solving systems using substitution. And we're going to remember how to do this. If x equals 3 and y, this is a slope-intercept equation, equals 2x plus 4. So we're going to do a substitution here. This is what we did on the first day of this unit. I'm going to plug it in right there. And that's going to give me y equals, what's 2 times 3? 6 plus 4. So y equals 10. Now what we have here is actually a point. This is 3, comma 10. 3, comma 10. So that's actually a very simple substitution that we just did there. But that's not what we need to be able to do. We have to ramp this up. Okay, so we plugged it in. We know how to plug it in. 3, 10. Yesterday, or in the last lesson, we talked about the transitive property and how we can set things equal to each other. I did a little video with bananas and apples and oranges. Now, this is where it all comes together. We are going to solve this system. Notice that I have 2 slope-intercept equations. This is a slope-intercept equation, and this is a slope-intercept equation. And using that y, see the y right there? The y is going to let me join the 2 equations into one equation. Okay, so back to our notes. We're going to take these 2 equations. Let me get my notes ready. Y equals 2x plus 4y equals x minus 2. Okay, back to our notes. Y equals 2x plus 4 and y equals x minus 2. We are going to join these 2 equations into one equation using the y. So here they are joining together. 2x plus 4 equals x minus 2. I have joined them together. Now I'm going to solve this and find the x value. This is what you did yesterday. We're going to solve it and find the x. This is all going in your notes. X equals -6. That's fantastic. We have the x. So we join the 2 equations together and we get the x. Now that we have the x, we still have to get the y. So how do I get the y? I plug in the x. So this is what we did on the first day. I plug in the x and I get the y. So let's take that -6 and we'll put it right here. 2 times -6 is -12. -12 plus 4 is -8. The y equals -8. And we just solved it. So I plug it in. I set y equal to y, so I turn it into one equation. I solve it. So right there, I'm solving it. I got x equals -6. And now I plug it in. I can either put it here for x or there. So I chose to put it in right there for x, but I could have put it over there. Let's see, if I put it right here, this is 2 times -6, which is -12 plus 4, which is -8. Or, ready, this is -6 minus 2, which is -8. Either way, it's going to be -8. I can plug it into either location. And I get -8. And there is my final solution. My final solution is at -6, -8. And remember, this is where 2 lines are crossing. If this is a coordinate system, if I have this coordinate system right here with x and y, Negative 6. Actually, I need to bring it over here, don't I? Whoop. Doing a good job, Mike. And negative 6, negative 8. So this is, it's this point right here. These aren't the lines, but it's kind of like boom, boom. That's not perfect, but it's that point right there. Ah! It's that point right there. It's where these two lines are crossing. These are two lines, and they are crossing at negative 6, negative 8. And I'm just getting too crazy with this drawing tool, aren't I? Stop that, Mr. Barre. Stop it. All right. So let's do a practice one. So my notes are done for today. Actually, no, they're not. Let's add one more thing to the notes. So this is the process that we're really doing. We're going to make a flow map here. Join equations using the y. So I join the equations using that y. I use y equals y so I can set the two equations together. I gotta go to something smaller that can actually fit on the page. Solve for x plug in x and get y. All right. So I join the two equations using the y, I solve it for the x, and then I plug in the x and I get the y. That's our flow. And what we end up with is some point x comma y. When we're done, we have an x comma y. Okay, let's do another example. Okay, so I'm done with the notes. The rest of this, I won't be checking on the note, but you should be still doing it to... Oh, look at that. I had a picture. That was so clever. Okay, here you go. Let's solve this system. If we're doing this in live, or if you're watching this live with me, you can solve it, and then you're going to give me your answer. If you're watching this not live, well, then you can still solve it and check your answer. Okay, do I have an answer for this on the next slide? I set the two equations equal to each other. I move the 4, I move the 3, and I get 2 comma 6. Did you get 2 comma 6? Let's do another one. Don't freak out right here. This one I know you're like, oh, Mr. Barre, that one looks so weird. Remember, this is just right? It's just a plus 0. And what's really right in front of this, let me change my color. What's right in front of this is, it's a negative 1, so don't freak out. Just put it, oh, man, you know what? That one turned out really good. Mr. Barre, dude, you're so good. Mr. Barre, you get a happy face for that. Happy face, Mr. Barre, happy face. It's a stick person. Hello. So you're solving this. If you're watching this live, we'll go over it in a moment. And you can pause me. So I have a solution at negative 2 comma 2. Negative 2 comma 2. All right, hey, that's my video. If you need help, you can come to my office hours and get help. And thanks for watching. Have a great day.